What's going on, everyone? We're going to start in just one moment here. We'll be learning about web development in the cloud. So look forward to that. Okay, let's see here. Hello, hello. How's it going, everyone? My name's Zane. I'm a streamer coach here at MLH, and today we're going to be talking about web development in the cloud, the intersection of the two. So should be a pretty fun time. Just going to get things sorted on my ends. Here we go. And we can just sort of jump right into it. Hope everyone's having a good morning, a good day, whatever it is where you are. Here in the US, early morning, but nothing gets me pumped up like some web development in the cloud. So there we go. Let's jump right in. Oh, here we go. Hello, hello. Got some people in the chat. Perfect. Okay, so with web dev in the cloud, we're going to cover web development, we're going to cover the cloud, and we're going to cover how the two intersect and augment each other. So we're going to go through a bit of the conceptual underpinning behind all of this and foundation of this all, because there's a bit to understand with everything. And if we have some time left, I think it'd be fun to try and start a little project, or at least explore some avenues for you guys to be able to explore how to interface the web, how to interface web development with the cloud. But without further ado, and if anyone has any questions or any comments, anything of the sort, please drop them in the chat. This is as much of a discussion as it is a it's as much of a discussion as it is a avenue for learning. If that makes any sense. So let's jump right in. Okay, so with web dev and the cloud, we should define them first. So web development refers to the process of building and maintaining websites or web applications. It involves a combination of programming, design, and functionality to create a user-friendly and visually appealing digital experience. Web developers use various technologies such as HTML, CSS, JavaScript, and server-side languages to bring websites and web applications to life. We'll look at a little bit of just how web technology has evolved very briefly in just a couple of minutes. But that's the gist of it. The cloud, on the other hand, in the context of computing, refers to a network of remote servers hosted on the internet that store, manage, and process data rather than on a local server or personal computer. So cloud computing provides on-demand access to a shared pool of resources, including storage, computing power, and applications, allowing users to access and use these resources over the internet. This model overall offers flexibility, scalability, and cost effectiveness, enabling individuals and organizations to leverage computing capabilities without the need for extensive physical infrastructure. So very, very helpful. Well, with that, let's go over a little bit on the, so let's cut off a little bit. It's not fun. But anyways, we'll walk through. So before we get really into what's possible nowadays with web development and how it interfaces with the cloud to help achieve that, I think it'd be fun to go over just basic history of web development, how it's evolved. So with this, we start with the early 90s, where there's the birth of the World Wide Web. Long story short, there's a computer scientist named Sir Tim Berners-Lee, a British computer scientist, who invented the World Wide Web. And in 1991, he introduced the first website and web browser, creating the foundation for what would become the modern internet. The early web was primarily text-based, and browsing was limited to basic hypertext links. In fact, you can actually go and see some fairly archaic stuff. If you look out these early websites. In fact, I was going to say, I'm pretty sure CERN actually has. Here, let's look at this. Look at the first website. So let's do this. This is actually the first page. As we can see, very, very basic, just text and hyperlinks, nothing too crazy. You can click through and see additional stuff here. Let's see, how can we help support the web? There we go, perfect. Anywho, early website. Hello, hello, what's up? Surfinia Burger, how are you doing? So birth of the World Wide Web, early text-based internet. In the mid-90s, we had the rise of HTML and CSS. The emergence of HTML, or hypertext markup language, and CSS, cascading style sheets, was, well, I guess pretty revolutionary for the time. HTML allowed developers to structure content, while CSS provided the means to style and format web pages. The separation of content and presentation became a fundamental principle in web development. In fact, it's actually a nice article that I was looking at before. I'll put it up on the screen, where it will help us walk through these different eras in web development. So as we saw, this was our early web. Now we have HTML and CSS, and look at that, how beautiful. So you can see how things are a lot more structured with the HTML. And now we actually have the option to style. So we have different colors, different fonts, bolding, so on and so forth. So I get the gist of it. We won't spend a million years on everything, but just pretty interesting to see how things have come along. But let's get to these next few points a little bit more rapidly. So in the late 90s, you have the dot-com boom in JavaScript. The dot-com boom was a period of rapid growth in which internet-based companies just really started manifesting. JavaScript was introduced by Netscape in 1995, enabling dynamic content on web pages. So this opened the door to more interactive and user-friendly websites. Early 2000s saw the establishment of web standards by the World Wide Web Consortium, or W3C. W3C actually has documentation that most web developers should know about, if you really want to get into the nitty-gritty on how things should get done. Again, web standards. W3C has some good resources. In fact, let's look that up. Take a look at W3C's site really quickly. Yeah, even nowadays, they're still at it. You can go through standards. I know we can get into like the nitty-gritty of it. Validation tools. Usually I find them by, validation tools. Anyways, if you really dive deep, you can find quite a bit about everything to do with your fundamental web technologies, your methodologies. Like I didn't even know they had these validators here. That's pretty nice. But anyways, nice to be compliant as a bona fide web developer. But with that, the early 2000s brought W3C, which ultimately brought greater consistency in how browsers interpreted HTML and CSS. And additionally, AJAX, or asynchronous JavaScript and XML, emerged, allowing for smoother asynchronous data exchanges between the browser and server, enhancing the user experience. Mid-2000s, we had content management systems in Web 2.0. So you had things like WordPress popping up. I'm sure most people at least have a bit of experience with WordPress, love it or hate it. So WordPress and Joomla, content management systems, gained popularity, simplifying website creation and management. Web 2.0 principles emphasized user-generated content, social collaboration, and dynamic, responsive interfaces. In the late 2000s, you had the mobile revolution and responsive web design really pop up. With the proliferation of smartphones, responsive web design became crucial. Ultimately, there was a big advocacy for websites that could adapt seamlessly to various screen sizes, from desktops to mobile devices. This is all the more important even nowadays. The majority of web content actually comes from smartphones now. So what a lot of web developers will actually do is prioritize. They'll design the mobile format of a website first and how it will look on mobile screens before they go on to design the site's layout for larger screen sizes. So I don't know, that just kind of floored me when I first heard about it. Because when you first learn web development, you always learn things from the perspective of desktop design. But really, mobile is kind of king. Or at least it's way too big to ignore, that's for sure. But with that, in the 2010s, we have single-page applications and JavaScript frameworks. So single-page applications are where a web application operates within a single HTML page. You have JavaScript frameworks like Angular, React, and Vue.js becoming instrumental in building complex interactive interfaces. Nowadays, in the present moment, progressive web apps are becoming, web development is essentially becoming characterized by progressive web apps, which provide a native app-like experience within a web browser. In full-stack development, which involves working with both front-end and back-end technologies, has become the norm for versatile and efficient web developers. In terms of what the future holds, we have technologies like WebAssembly, promising near-native performance in the browser, and Web 3.0 envisions a more intelligent, decentralized web experience driven by advancements in artificial intelligence, blockchain, and immersive technologies. So as we can see, the evolution of web development from its beginnings as a text-based system to the dynamic, interactive, and complex web applications we have today is a journey that just continues on and on and on. The innovations of the cloud and what they mean for web development are what we're going to focus on in particular, but just nice to have a little bit of background. That being said, let's go into cloud computing in modern web development. So cloud computing refers to the delivery of computing services, including storage, processing power, and applications over the internet. As we delve further into the 21st century, the landscape of web development is increasingly shaped by the transformative power of cloud computing. This paradigm shift has become a linchpin for modern web development, offering a range of benefits that have revolutionized the way applications are built and deployed. The cloud brings several advantages to web development, enhancing the way applications are built, deployed, and maintained. We'll cover just a few of them. So for one, there's scalability. Cloud services allow web applications to easily scale resources up or down based on demand. This scalability ensures that websites can handle fluctuations in traffic without the need for significant upfront investments in hardware. Second is cost efficiency. Cloud computing follows a pay-as-you-go model where users only pay for the resources they consume. This eliminates the need for large upfront infrastructure investments and allows developers to optimize costs based on usage. Third is flexibility. Cloud platforms provide a variety of services and tools, offering flexibility in choosing the right technology stack for web application. Developers can easily integrate different services, frameworks, and languages to meet specific project requirements. Fourth is global reach. Cloud services are distributed across data centers worldwide. This allows web applications to be hosted closer to end users, reducing latency and improving performance globally through content delivery networks, which we'll cover in more detail later. Fifth is reliability and availability. Cloud providers typically offer high levels of reliability and availability. With data redundancies, backup mechanisms, and robust infrastructure, the chances of downtime are minimized, ensuring continuous accessibility for users. Sixth is security. Cloud providers invest heavily in security measures, including encryption, access controls, and monitoring. Storing data on reputable cloud platforms often provides a more secure environment compared to self-hosted solutions, especially for small to medium-sized businesses. Next, have automatic updates. Cloud services often handle infrastructure updates, security patches, and maintenance tasks automatically. This reduces the burden on developers to manage these aspects, allowing them to focus more on coding and application functionality. And just three more here. Collaboration and integration. Cloud platforms facilitate collaboration among developer teams by providing centralized storage, version control, and collaborative tools. Additionally, cloud services easily integrate with various third-party services, enabling developers to leverage a wide range of tools and APIs. Just curious, for those watching, who here has looked into this sort of stuff before? Like just exactly how deeply cloud computing goes on to, well, I suppose just optimize everything to do with computing. And two, who here has explored the interfacing of cloud computing with modern web development? I'm going to be covering it more and more detail in just a second, but I'm always curious. It's there's a lot of, I've done web development for about 1.5 years myself. I'm kind of moving away from it at this point, but I still have an interest. I still kind of like seeing what's on the horizon, the newest things that people are embracing. It's pretty exciting stuff and all. But anywho, cover these last 2 points. So collaboration and integration. We next have disaster recovery. Cloud services offer built-in disaster recovery capabilities. Regular backups, data replication, and recovery features ensure that in the event of data loss or system failures, developers can quickly restore applications to a previous state. And lastly, we have innovation acceleration. Cloud providers continuously introduce new features and services. Developers can leverage these innovations to enhance their applications without needing to build and maintain the underlying infrastructure themselves. So as we can see, overall, the cloud transforms web development by providing a scalable, cost-effective, and flexible environment, allowing developers to focus on building robust and feature-rich applications. So moving forward with that, and really focusing on what cloud computing brings to web development in and of itself, and or more specifically, I should say, we can get into the cloud infrastructure for web development. I'm going to start with that with covering cloud service models. So a cloud service model refers to a category of cloud computing that defines the level of control and responsibility users have over their computing resources. It outlines the extent to which cloud service providers manage infrastructure, platform components, or entire software applications on behalf of users. These models ultimately provide a framework for users to leverage cloud resources based on their specific needs and preferences. So we have 3 basic cloud service models that we'll cover: infrastructure as a service, platform as a service, and software as a service. Understanding and choosing the appropriate cloud service model is crucial for organizations and developers because it dictates the level of control, management, and customization they have over the computing environment. The right choice can impact factors such as flexibility, scalability, development speed, and maintenance efforts. And each model caters to different use cases and aligns with specific business requirements. So infrastructure as a service provides virtualized computing resources, granting users full control over virtual machines, storage, and networking infrastructure. Platform as a service abstracts infrastructure management, offering pre-built development frameworks and tools to streamline application development and deployment. And finally, software as a service delivers fully functional software applications over the internet, eliminating the need for local installations and maintenance while offering a subscription-based model. So I'm going to jump into these 3 in a bit more detail here. For infrastructure as a service, just some things to know. It shines in control and flexibility. In terms of control, it provides the highest level of control over infrastructure components, allowing users to manage virtualized servers, storage, and networking. For flexibility, it offers in terms of operating systems, applications, and configurations. As for use cases, ideal scenarios, it's ideal for scenarios requiring control over the entire infrastructure, such as custom application development and hosting. And just a bit more on it in all. I guess the best way to sum it up is being a cloud computing model that provides virtualized computing resources over the internet. And clients can rent virtualized hardware, including servers, storage, and networking components, rather than investing in and maintaining physical infrastructure. Again, for infrastructure as a service. It relies on virtualization technology to create virtual instances of physical hardware, enabling multiple users to share the same underlying physical resources. And as a result, users can scale their infrastructure up or down based on demand, paying only for the resources they consume, like we just mentioned a second ago. And it often provides a self-service model, allowing users to provision and manage resources independently. Some example providers of infrastructure as a service is Amazon Web Services, Elastic Compute Cloud, Microsoft Azure Virtual Machines, and Google Cloud Compute Engine, which we'll cover in a little bit when we talk about, I'm going to talk a little bit about Shopify and how they've ultimately moved their strategy to, they've embraced the cloud and cloud computing in their business model and in their application. So with that, it's best to choose infrastructure as a service as one's cloud service model when granular control over the infrastructure is crucial, such as in scenarios where custom configurations are required. But with that, that's infrastructure as a service. Next, we'll cover platform as a service. So platform as a service is a cloud computing model that provides a platform allowing customers to develop, run, and manage applications without dealing with the complexities of infrastructure management. So it abstracts away the underlying infrastructure, allowing developers to focus on building and deploying applications. Some of the key characteristics are abstraction of infrastructure, as we said. It abstracts infrastructure components, automating tasks like provisioning, configuration, and maintenance. Another key aspect is development frameworks. Platform as a service often includes pre-built development frameworks and services that accelerate application development. Lastly is automatic scaling. These platform as a service platforms typically offer automatic scaling to handle varying workloads without manual intervention. In terms of use cases, it's best for application development. In terms of developing applications without worrying about underlying infrastructure, and web application hosting. Very much suitable for hosting web applications that require rapid development and deployment. Some example providers of platform as a service would be Heroku, Google App Engine, and Microsoft Azure App Service. And lastly of these three is software as a service, which is also a cloud computing model that delivers software applications over the internet on a subscription basis. So that's its contrasting part, delivering software applications over the internet on a subscription basis. Users access the software through a web browser without needing to install or maintain the application on their local devices. So key characteristics of it include accessibility, as in being accessible over the internet, which eliminates the need for local installations. Automatic updates, where providers handle updates and maintenance tasks, ensuring users they always have access to the latest features. And finally, the subscription model. So software as a service is typically offered on a subscription basis, allowing users to pay for the software as a service. Use cases include email and collaboration tools. So it's widely used for email services, collaboration tools, and productivity applications, as well as, or another use case is customer relation management. So many CRM solutions are delivered as software as a service tools. Some example providers include Salesforce, Microsoft 365, and Dropbox. So in terms of choosing between these three, in terms of choosing between infrastructure, platform, or software as a service, kind of comes down to general use case paradigms, I suppose you could say. So you'd want to choose infrastructure as a service. As I said before, when granular control over the infrastructure is crucial. You'll want to choose platform as a service for rapid development. When you want to focus on rapid application development, automated scaling, and minimizing infrastructure management efforts. And lastly, you want to opt for software as a service for ready-to-use solutions without the hassle of local installations, updates, and maintenance. So in essence, the choice amongst these three depends on the specific needs of a project, the desired level of control, and the trade-offs between customization and ease of use. Each model offers a different balance of responsibilities between the cloud provider and the user, allowing for tailored solutions based on diverse use cases and business requirements. Here, let's see, we got a question from Regaltos. Which one could be cost effective? Is it in stage-wise, my app development, like at starting stage, the maintaining? In terms of, so it seems like you're asking two questions. First is, I guess the first would either be which one is the most cost effective, or which among these are cost effective as a whole? And then it seems like the second question is, where does it save you that cost? And these costs, could be both money or time. We'll kind of cover that sort of stuff in detail, but if you want to clarify your question a little bit more, I might be able to expand on it. I might be able to expand on my answer to help you a bit more with that. But there's a few things that we'll cover later on with pay-as-you-go solutions with the cloud that will definitely help. In fact, we actually covered this a tiny bit in our last slide. We were talking about cloud computing as a whole. One aspect of cloud computing is just being is just cost efficiency. So as a whole, cloud computing follows a pay-as-you-go model where users only pay for the resources they consume, which is super efficient because it eliminates the need for large upfront infrastructure investments and allows developers to optimize costs based on usage. So just cloud computing as a whole is really cost efficient compared to traditional methods. But in terms of these specific cloud service models, I think it may depend on the context of what it is that you're trying to achieve and which one makes the most sense. So I hope that gives some additional insight, clarification. But yeah, I mean, if you want to clarify your question or just add anything to it too, we could definitely talk more on that. But yeah, as you were saying, so of these three, infrastructure, platform, and software as a service, each model offers a different balance of responsibilities between the cloud provider and the user, allowing for tailored solutions based on diverse use cases and business requirements. So that's those three. Understanding these models empowers developers and businesses to make informed decisions based on their unique goals and constraints. So that is cloud service models in a nutshell. Now we're gonna, excuse me, still pretty early morning here. But with that, we're going to kind of extend, well, not extend this concept, but we'll kind of take the next step on various approaches that can be utilized within these various cloud service models. We are going to talk about containers and microservices. So containers and microservices. In fact, you guys probably heard of these sorts of things before, like you've ever heard of Docker, Kubernetes, anything along that line that gets you within your containers. In microservices, I'm actually not I think that's more of like a methodology than anything. I don't know if there's I'm sure there's specific tools that help manage that. Like, don't know of any off the top of my head. In fact, I've never really looked into microservicing or microservices until I was reading about all this stuff while putting together this stream. But it's pretty interesting. We'll definitely learn about it in just a moment here. So anyways, containers and microservices are architectural and deployment approaches that can be utilized within various cloud service models. So our cloud service models being, again, like we just covered with the infrastructure as a service, platform as a service, and software as a service. So containers and microservices both are not only compatible with, but also optimized for cloud infrastructure. They leverage cloud services and features to enhance the development and deployment of web applications, making them more scalable, flexible, and efficient in the dynamic cloud environment. So let's go into detail on containers. Oops. Whoa, hold on. My browser just completely flipped out. Okay, so let's go into detail on containers. So just to explain a bit about containers, think of them as like moving boxes for software. When you want to move your belongings from one place to another, you pack them into boxes. Similarly, when developers create software applications, they can pack them into containers. Inside these containers, you have everything the software needs to run smoothly: the code, libraries, and other tools. It's like a little package that contains everything required for the software to work, no matter where it's being run. Containers ensure that the software runs the same way, whether it's on your computer, in a testing environment, or even on a big cloud server. So this consistency is really the key to containers. It's the heart of it all. It's why we use them. Ultimately, it makes it easier for developers to build, test, and deploy their applications without worrying about differences in the environments. So the benefits are pretty amazing, as you can probably imagine. One of which being portability. Containers can run anywhere, as we said, making it easy to move applications between different computers or cloud platforms. They're also efficient. They're lightweight and use resources more efficiently than traditional ways of running software. Some additional things to know about them is that cloud platforms often provide, well, just kind of understanding the interfacing between containers and cloud platforms a little bit more. Cloud platforms often provide container orchestration services, such as Kubernetes, which I'm sure at least a few of us have heard about, if not everyone. So cloud platforms often provide container orchestration services such as Kubernetes, which automate the deployment, scaling, and management of containerized applications. Containers seamlessly integrate with cloud services, enabling developers to leverage cloud-based resources like storage, databases, and networking in conjunction with containerized applications. As we said, containers are lightweight and resource efficient, making them well suited for dynamic scaling and efficient utilization of cloud resources. Containers provide consistency across various cloud environments, facilitating portability and reducing dependency on specific infrastructure configurations. Facilitating portability and reducing dependency on specific infrastructure configurations. And containers are used within those three web paradigms that we've covered before: infrastructure, infrastructure, platform, and software as a service. They provide a standardized way to package and distribute applications, promoting portability and consistency across diverse cloud environments. So, yes, containers are very much a natural extension of cloud computing. What's going on, Strata? Hope you're having a good day today. So those are containers. So as we said, in essence, kind of like packages for software that can run anywhere and ensure that the software runs the same way in whatever environment, irrespective of whatever the environment may be even. So that's containers. Let's jump into microservices. So the best way to understand it, imagine you have a big task to complete, like building a house. Instead of doing everything at once, you can break it down into smaller tasks. So one team can work on the foundation, another on the plumbing, and so on. Each team focuses on its specific job. Microservices is a way of building applications like building a house. Instead of creating one big piece of software, developers break it down into smaller, independent parts called microservices. Each microservice has its own specific job or function. One might handle user authentication, another manage another manage payments, and so on. Just like with building a house, it's easier to work on and manage smaller, focused tasks. Some of these benefits are flexibility, where developers can update or change one part without affecting the whole application. Scalability, if one part of the application needs more resources, only that specific microservice can be scaled up. And it leads to easier maintenance as a whole. Fixing or updating one part doesn't require touching the entire application. There's a few, or I guess that's microservices in and of itself. It often interfaces with containerization as well. So microservices are often containerized, making it easier to manage, deploy, and scale individual services within a cloud infrastructure. And two, when we talk about microservices with integrating it with the cloud, you can very much integrate it with cloud native services. So microservices can leverage cloud native services like serverless computing, managed databases, and API gateways offered by cloud providers. And microservices architecture can be applied within the context of various cloud service models as a whole, as we can see, allowing developers to structure and deploy applications as a collection of independent, loosely coupled services. So putting the two together, containers and microservices, they often do work together. Each microservice can run inside its own container, providing a neat and organized way to manage different parts of a complex application. The overall benefits of this pairing leads to scalability, to where you can scale up the parts of an application that need more power without affecting others. And it leads to efficiency, as containers make it easy to manage and move these microservices around, which ensures that your application runs smoothly no matter where it's located. So in a nutshell, containers are like neat packages for software, and microservices are like small, specialized teams within these packages. Together, they make it easier to build, manage, and scale complex applications. So I'm curious, who here has delved into containerization and microservices? If only one or the other, or if both. I'm actually curious. I know that after this stream, we're actually going to have a stream with Wei on Docker and Dockerization. So if you're interested about containers, definitely stick around for that. Got some activity in the chat. Got Shraddha. You're doing good, and the stream makes it even better. Perfect. I love to hear that. I'm trying my best here. If all I do is put some smiles on your guys' faces, then, well, I consider that a job well done. Well, we got Regaltos. Microservices, are they independent? What could be the design if other services dependent on other? So, yeah, microservices in and of themselves are independent. So, in fact, that's kind of the heart of the concept. So, as we talked about just a second ago, tackling an application from a microservices approach would be like having user authentication being its own separate thing, as well as what was the other example that I had? I just don't want to speak improperly here. Put a bit of research into this stuff, so I want to make sure that I lean on that more than anything. So yeah, so as I said, each microservice has its own job or function. One might handle user authentication, another might handle payment, so on and so forth. I actually haven't looked into it this deeply to really give a concrete answer, but I'd imagine that this might manifest in things like when you sign up for a website and you have that like auth 0 sort of thing pop up for user authentication, or maybe even like when you're trying to sign into a website and you have the option to sign in with Gmail. or if you're trying to use payment on a website and you have like a little PayPal integration pop up. I can't say for certain if that is like an example of microservices, but I'd imagine that it's kind of in a similar spirit. So, well, anyways, I hope that gives some clarification on maybe at least things that you can explore with it in Regaltos. They're most definitely independent, since that's kind of at the conceptual foundation of microservices. So, and you can see, like, if you're putting together a website or web application, like every web application essentially, or if not all, then a lot of them will need things like user authentication, or they'll need things like payment solutions. So I'd imagine that's where you have things like Auth0 or like PayPal or Stripe or whatever, having their own like embedded little application that allows you to interface with the larger application as a whole to complete those sorts of tasks. Just my hunch. So I once installed Docker and it stopped my VirtualBox. It broke your VirtualBox as a whole? But I really want to work with it. Yeah, I mean, stop by Way's stream. It's right after this one. It's about in an hour and 20 minutes, I believe. So I think he might be doing a series on Docker, in fact. So definitely check that out. Got it. Thanks. I will explore. Awesome. Yeah, I hope at the very least, I hope this stream helps people get more overall cognizance of cloud infrastructure and just sort of where to look more. This is I actually learned everything that I put together here once I was tasked with this stream. I've heard about things like Docker, Kubernetes, mainly containerization over everything, but I'd never really delved into deep detail on any of this. So it was actually a lot of fun putting this together. Definitely taught me a lot. Let's see. So in terms of the VirtualBox crashing, I guess that was due to Hyper-V. Once I uninstalled Docker and reinstalled the virtual machine, it worked fine. Okay. Yeah, crazy. Well, thankfully it was all resolved. But again, any other questions or comments, anything of the sort, by all means, drop them in the chat. But I'm going to cover a little bit more on what we're talking about, the interfacing of containers and microservices. So again, containers are like neat packages for software. Microservices are the small specialized teams within these packages. As for their roles within cloud service models, in the interface, as the infrastructure as a, what am I saying? With infrastructure as a service, containers and microservices allow developers to have more control over the infrastructure, deploying and managing applications in a modular and scalable manner. In platform as a service, microservices can be leveraged without the need to manage low-level infrastructure details, focusing more on application development and deployment. And on software as a service, while software as a service typically provides ready-to-use applications, microservices can still be part of the underlying architecture, allowing for flexibility and customization within the application. Just a couple other aspects to cover with containers and microservices, like in the realm of DevOps practices. So containers and microservices align with DevOps practices, enabling the automation of continuous integration and continuous deployment pipelines, which are essential for efficient development workflows in the cloud. And lastly, another aspect of DevOps practices with containers and microservices would be infrastructure as code. So cloud infrastructure, including container orchestration and microservices configurations, can be defined and managed as code, promoting consistency and reproducibility. The last little point here on containers and microservices deals with content delivery networks. So cloud platforms often integrate with content delivery networks, facilitating the global distribution of containerized and microservices-based applications to reduce latency and improve user experience. So with that, we will just keep moving on. So let's see. So we covered cloud computing kind of in and of itself, and we touched briefly on how it interfaces with web development. Then we covered cloud infrastructure for web development, where we have infrastructure, platform, software. Now we've covered containers and microservices and how they help streamline the development process and just the very nature of web applications and how they interface with these cloud service models. And now we'll continue on to cloud-based web dev tools and frameworks. So as we can see, we're going to cover these three things in detail: serverless computing, cloud-based databases, and content delivery networks. So in the rapidly evolving landscape of web development, leveraging cloud-based tools and frameworks has become essential for creating scalable, responsive, and dynamic applications. We'll cover serverless computing, cloud-based databases, and content delivery networks to better understand the latest effective solutions. So let's start with server infrastructure. Server infrastructure refers to the underlying hardware and software components that support the deployment, operation, and management of computer servers. Servers are powerful computers designed to process requests, host applications, store data, and manage network resources. Server infrastructure encompasses both the physical servers, hardware, and the software that enables their functioning, including operating systems, networking protocols, and server applications. So as to why server infrastructure is important, one aspect is resource allocations. Servers allocate computing resources such as CPU, memory, and storage to applications and services, ensuring they have the necessary resources to function effectively. Another aspect is data storage. Servers are responsible for storing and retrieving data. They host databases, file systems, and other storage solutions critical for applications and users. Application hosting. Server infrastructure hosts and runs applications, websites, and services, making them accessible to users over networks. Network management. Servers play a key role in managing network traffic, routing data between different devices, and facilitating communication within a network. And finally, computational power. Servers provide computational power for tasks that require processing capabilities beyond what individual devices can handle. In fact, my hunch is that that is especially where infrastructure as a service comes in. And as we said, relies on virtualization technology to create like virtual emulations of hardware. I don't know. Don't quote me on that, but that's the first thing that came to mind as I was going over that again. So anyways, server infrastructure. So we're going to talk about the traditional approach to server infrastructure, and then we're going to contrast it with the cloud-based approach of serverless infrastructure. So in traditional server infrastructure, applications are hosted on physical servers or virtual machines that run on dedicated hardware. Each server is responsible for specific tasks, such as handling web requests, running applications, and managing databases. There's a couple things to know about this model, this traditional server infrastructure model. Number one is server provisioning. Organizations need to provision and manage servers, deciding on the number of machines, their configurations, and allocating resources such as CPU, memory, and storage. This all brings scalability challenges. Scaling in traditional infrastructure often involves vertically scaling servers by adding more resources to a single machine, or horizontally scaling by adding more machines. This process can be time-consuming and may lead to inefficient resource utilization. There's also maintenance overhead that comes with this. Regular tasks like software updates, security patches, and system maintenance are manual processes that require attention and time from IT teams. Failures or issues often require immediate attention to prevent disruptions. And then finally, on this traditional server infrastructure, another aspect to consider is cost implications. Organizations must invest in infrastructure, whether physical servers or virtual machines, even during periods of low demand. This can lead to suboptimal cost efficiency as resources are allocated regardless of the actual workload. So that's traditional server infrastructure, with both kind of in its full nature, for better or worse. But what we're particularly interested in is serverless architecture. Here, let's see, we have, just saw your comment here, Shraddha. I've always heard about containerization and microservices, but have no clue how to incorporate them into a project. Would a small project really need them? That is actually a good question. I myself, I've never actually utilized them myself. I just know about them, and I kind of know like general nature to them. Especially now, I think we kind of all do now that we've covered the basics of it at least. But I guess it would really depend on the small project. And well, I guess containerization, I could maybe see if the small project has enough of a unique, how would I say it? If it would have issues running on like varied environments, then I'm sure containerization would definitely help. But in terms of microservices, I'm not entirely sure. I mean, if I'm correct in that, maybe something like a payment solution, like those embedded like PayPal or Stripe or whatever it is that you see on websites. If you see those, then like I get like a particular microservice you could probably recycle in different contexts, right? At least that's my thought. Again, I have no idea if that is actually how any of this works. Just to be completely transparent with you, at least to that level of detail. But it's definitely worth thinking about. Definitely worth researching. What I've seen, it seems like companies like it if people at least have a general cognizance of those things. Kind of shows that they're tech forward. But again, it might depend on the company and the like. I actually almost I was playing around with Docker, or I actually didn't play around with it yet, but I had the plan to play around with Docker with one of my projects that I submitted for the MLH fellowship. So that was fun. At least to look into it. I never got around to actually implementing it. But I'd like to look into it sometime. I think it'd be interesting. Anyways, so for server infrastructure, because ultimately going to cover serverless computing. For server infrastructure as a whole, again, just a brief recap as we get back into this. Server infrastructure refers to the underlying hardware and software components that support the deployment, operation, and management of computer servers. And we covered traditional server infrastructure at first, where applications are hosted on physical servers or virtual machines that run on dedicated hardware. Each server is responsible for specific tasks, such as handling web requests, running applications, and managing databases. So, and we kind of covered some of the challenges with that, right? Scalability challenges, maintenance overhead, cost implications, server provisioning. So let's look at the cloud approach to this, serverless architecture. So serverless architecture is a cloud computing paradigm that allows developers to build and run applications without the need to manage traditional server infrastructure. The term serverless in the context of cloud computing doesn't mean that there are no servers involved. Rather, it refers to the model where the management and provisioning of servers are abstracted away from the developers. In a serverless architecture, developers don't need to explicitly deal with server-related tasks such as server provisioning, scaling, or maintenance. The cloud provider will deal with these, allowing developers to focus solely on writing code and defining functions. So isn't that nice? Separation of concerns in a way. So we'll touch on a few aspects of server infrastructure and how the traditional approach and how the serverless approach compare. So number one is the abstraction of infrastructure. The traditional perspective on this In traditional server setups, developers are responsible for server provisioning, configuring, and maintaining the infrastructure to run their applications. So this includes tasks like operating system updates, security patches, and server scaling. Whereas with serverless, developers in a serverless model interact with a cloud platform that abstracts away the underlying infrastructure. So they don't need to provision, manage, or maintain physical servers, virtual machines, or containers. That's all on the cloud provider. Second aspect of traditional versus serverless deals with event-driven models. In traditional server setups, designers must design, deploy, and manage the application across servers or virtual machines. They need to handle traffic management, scaling, and load balancing manually. Whereas with serverless, developers write functions that respond to specific events or triggers. These functions are stateless and execute in response to events such as HTTP requests, database changes, or file uploads. So again, just very abstracted out. And I suppose automated too. Third is automatic scaling. In traditional setups, scaling often requires manual intervention. Developers must plan and implement scaling strategies to accommodate increased traffic or demand. Whereas with serverless, it automatically scales the number of function instances based on the incoming workload. Developers don't need to configure or manage the scaling process as a result. Fourth is the pay-as-you-go model. In traditional setups, organizations often pay for continuous server uptime, regardless of the actual workload. This can lead to suboptimal cost efficiency during periods of low demand, as we touched on just a minute ago. Whereas for serverless, users are billed based on the actual resources consumed during the execution of their functions. There's no need to pay for idle resources. That's super cool to me. I love that. So another aspect, traditional versus serverless, managed services. In traditional setups, developers are responsible for routine maintenance, security measures, and ensuring the health of the servers. While for serverless, cloud providers offer managed services for functions, handling operational tasks like server maintenance, security, and updates. Again, there's kind of like a separation of concerns, which is just very nice. And there's a couple other things. Stateless functions, we kind of touched on this a second ago, but in traditional setups, state management and scalability may require additional considerations and configurations. Whereas in serverless, functions in a serverless architecture are designed to be stateless, executing specific tasks and terminating. This allows for efficient resource utilization and automatic scaling. And as a whole, the serverless model enables rapid development and deployment. Developers can quickly build, test, and release functions without dealing with the complexities of server management. So as we could see, serverless really builds upon and expands, and I guess you could almost say supersedes the traditional server model, at least in like this general overview that we're having. So as a whole, serverless computing improves upon traditional server infrastructure by offering a more efficient, scalable, and cost-effective approach to building and deploying applications. It enables developers to shift their focus from managing servers to writing code, fostering agility, and accelerating the development cycle. So here, let me take a drink of water here. Almost an hour in, we are. Crazy. Time flies when you're talking about web development in the cloud. That's for sure. So with that, yes, it certainly does. It does. It does. Stuff is it's pretty interesting. I did front end web development for a while, kind of purely dealing with like HTML, CSS, JavaScript. I did a bit of like React, Next.js, and all, but I was mainly focused on like learning the skills to make basic static websites for small businesses. But I didn't really find it that interesting at the end of the day. I just realized I didn't really care about websites like that. But this sort of stuff, getting more into the back ends and the efficiency of systems and all of that, I find it super incredibly interesting. I don't know if I would like specialize in this sort of stuff specifically, taking more of an interest in like controls, embedded systems, stuff like that, and data analysis. But I still find this pretty fascinating. It sounds like you've delved a bit into it all too, Shraddha. I'm just kind of curious, like what's your experience with like web development in the cloud, either independently or in and of themselves? See Rialtos. True, it's good when we watch on Twitch Cloud interactive chat, which has background microservices running. Yeah, I could imagine. Did you look into it a little bit? I'm sure that chat solutions like I'm sure that there exists like chat solutions like man, I can't think off the top of my head, but I definitely have seen websites where they've had like independent chat application that they utilize, and that's like integrated into their service. Let me go get let me plug my laptop in. Here we go. Anywho, but yeah, now I'm curious about both of you, Shraddha and Regaltos. We got you guys active in the chat. Just curious, like what's your story with just the cloud, looking into it, utilizing things, anything of the sort? Are you brand new to it? Is this like your first time hearing about it? Or have you delved into it yourself? Have you made any projects? Do you have any goals with them? So on and so forth. So anyways, we just covered serverless computing as a whole, which, as we can see, ultimately allows developers to build and run applications without the need to manage traditional service infrastructure. We'll next delve into cloud-based databases. So, well, before that, actually, let me take another drink because my throat is about to dry out. So, let's start with what databases are and why they're important. So, databases are organized collections of data that can be easily accessed, managed, and updated. They serve as central repositories for storing, retrieving, and manipulating data in a structured and efficient manner. Databases provide a way to organize and store information in a way that supports efficient retrieval, analysis, and management. So as to why they're important, there's a few key things to touch upon. First is for data organization. So as we said, databases provide a structured and organized way to storage large amounts of data. This organization is essential for efficient data management and retrieval. Another reason is data integrity. Databases enforce rules and constraints to ensure data integrity. This includes maintaining consistency, accuracy, and reliability of data. Another important point is data retrieval. Databases offer powerful query languages that enable users to retrieve specific information from large datasets quickly. They also offer things for data security. So databases implement access controls and authentication mechanisms to secure sensitive information, ensuring that only authorized users can access and modify data. And our last important point here is concurrency control. In multi-user environments, like if you're working with a team, databases implement mechanisms to control concurrent access to data, preventing conflicts and ensuring data consistency. So databases are pretty important for dealing with data in a efficient and just practical manner, really. So why databases are used? We can kind of get an idea of just talking about what we did just there, but just to be a little bit more on the nose with it. One is for structured storage. Databases provide a structured way to store and organize data, which is crucial for applications that need to manage large volumes of information. Data retrieval. offers efficient and fast data retrieval mechanisms through queries, as we said, enabling users to access specific information. They also support complex queries and aggregations, making them suitable for data analysis and reporting. And just one more additional benefit is the establishment of relationships between different sets of data. It allows you to do, which ultimately supports complex data models. So that's databases as a whole. Right? It's all about organizing collections of data for easy access, management, and use. And it's very important just because for exactly that. So now in terms of databases in web development. Let's see here. We got more stuff in the chat. So zero experience in web dev. I've worked with cloud like Azure, SDK, peer-to-peer, just as tokenization. Okay. So what did that entail exactly? Like, did you have a specific project that you were working on? And what do you think you took away from it as a result? Like, were there particular things that you learned about it? Or particular things that just kind of give you a headache? Curious what your experience was like with that. So from Shraddha, talking about web development, front end was never really my thing. So I moved to work on virtual machines, web app frameworks, Google Cloud with all of its cool games for students. What sort of games are there? I never looked into it. Are they like programming focused games, or are they just like games that you'd actually like, I guess games to play for game's sake? Are they fun in and of themselves, or is it more so fun just as a way to utilize the cloud? Anywho, so we covered databases. Just in terms of what they are and why they're important. Now let's go into a bit more detail on why databases are used in web development. So one big reason is for user data storage. Web applications often need to store user data, such as profiles, preferences, and account information. Databases provide a reliable and secure way to manage this information. Another use is for content management. Websites and web applications frequently manage content such as articles, blog posts, images, and videos. Databases enable efficient storage and retrieval of this content. So it's good for session management. Databases are used to store session data, allowing web applications to maintain user states and preferences across multiple interactions. Come in handy for e-commerce transactions. Databases are crucial for handling transactions, managing product catalogs, and tracking inventory in e-commerce applications. And then for data-driven applications, many web applications rely on dynamic and data-driven content. Databases support the storage and retrieval of this dynamic information. And then lastly, for us, scalability. Databases support the scalability of web applications by efficiently managing data as the user base and data volume grow. So in all, databases play a vital role in web development by providing a structured and organized way to store, manage, and retrieve data. They ensure data integrity, support complex queries, and enable efficient data analysis, contributing to the functionality and reliability of web applications. So we covered databases, what they are, why they're important, how they're used in web development. Now let's talk about non-web-based databases versus web-based databases. This is going to get us into the cloud here. So for non-web-based databases, we'll talk about deployment, access mechanism, security and control, scalability. As for deployment of non-web-based databases, they're traditionally deployed on local servers or private networks. Access to these databases is often limited to users within the same network. Access mechanism. Users interact with non-web-based databases through dedicated client applications installed on their devices. These applications connect directly to the database server. For security and control, all these databases are deployed locally. Organizations have direct control over security measures, access permissions, and infrastructure. And then for scalability, scaling non-web-based databases may require hardware upgrades or manual configuration adjustments. can be a more complex process compared to web-based databases. Now, as for web-based databases in these areas, as for deployment, web-based databases are hosted on servers accessible through the internet. Users can interact with them using web browsers, making them more widely accessible. In terms of the access mechanism, users can connect to web-based databases using web browsers, and interactions are often facilitated through web applications. This allows access from various devices with internet connectivity. For accessibility, of course, web-based databases provide greater accessibility, allowing users to connect from different locations and devices, promoting collaboration and remote work. I think that's actually like pretty huge, honestly. Security measures typically implemented at both the application and database levels. Access control, encryption, and authentication are managed by the web application. Finally, scalability. Web-based databases can benefit from the scalability features of cloud computing, enabling automatic scaling based on demand. Cloud providers handle infrastructure scaling, reducing the burden on organizations. So again, we're just seeing all the fundamental benefits of cloud computing just showing up again and again. Well, here, let's see. We got some more content in the chat. Arcade, Q Week Labs, Google Cloud Labs. Are those like different things that you worked with? I think I might have stepped away from the conversation a little bit too long, lost context. Oh, I guess these are the different games, right? Okay, so kind of I have live streaming, sending code packets to cloud. So this was on your one project, right, where you worked with the cloud with Azure peer-to-peer just as a tokenization. So live streaming, sending encoded packets to cloud and store them there, then do some computation, send data from local to cloud, virtual machine, used Azure. Okay, interesting. Not gonna lie, that is something that I've never dealt with before in any way. So I'll have to look into that to kind of see how it works. If either you have any like resources or like any links of just like learning this stuff that you yourself took on, that'd be interesting. I'd love to look into it. It was me who advised you to work on different projects and decide what you liked based on that. That's right. I remember that. Yeah, we actually had a pretty good conversation on that. Maybe that was the stream I might have did on open source and data science. I actually gave that presentation in the cafeteria at school, funnily enough. It was late in the evening and basically no one around. So Arcade is the game where we get hands-on experience in Google Cloud Services and earn points and swags. Okay, interesting. But yeah, I'm glad that it helped clarify things for you. So was it from that did you like kind of rethink about front-end web development and then realize you wanted to go more into the like virtual machines and framework side of thing? I'm still figuring this stuff out for myself, funnily enough. I think I definitely talked on it a little bit last time. Super into front-end web development, as I talked about a few moments ago. But now I'm more interested in, I don't know, just like using websites and everything to do with websites and the web. Just doesn't really interest me all too much anymore. More so interested in just insights that you can get either interfacing directly with the natural world or about just insights that you can get from phenomena in the natural world. So that's kind of leading me down more hardware focused things like controls or embedded systems, or things dealing more with like data analysis and statistics and all that. I think AI is pretty interesting too, because AI is kind of like distilled human ingenuity. And there's something about that that's just so inherently captivating and interesting to work with. That's right. Yeah, open source and data science. Yeah, again, these kind of streams are cool because I again, like I didn't really know very much about data science before I started looking into it for that. And I didn't know very much about cloud-based things in web development until I put together this here. So it's pretty slide heavy. That's because like these sorts of streams that I do, mainly because I don't really have the overall cognizance to really talk intelligently through, like, say, a basic project. Um, Hoping to give more of a general overview of these sorts of things so that if people do have an interest in it, if something does pique their interest, and kind of they can look into basic projects that they can do, because I'm sure online there's a million like tutorial projects in just about every domain. And with that, they'll have a bit better of an overall cognizance of just what goes on in the worlds of these areas, so that when terminology is thrown around or you have basic concepts introduced in like your tutorial projects, they like you're already kind of familiar with it. Like things, bells will ring, things will kind of click a little bit more. So, are the current buzzwords really? Yeah, I mean they're really popular. Everyone's trying to get in on it right now. I mean, I think it's definitely going to stay around. I think it's definitely going to never go away and definitely be pretty big, especially as AI gets better and better. But I don't know. Like originally, I was going to go to school for computer science, focus on software engineering primarily, and then I had just realized I had a little bit more interest in more as using computer science as a how can I say this, as a tool. I mean, that's what computer scientists do too, but um, I don't know if I want programming in and of itself to be the primary thing that I do all day, every day, just in and of itself. I'd definitely be interested in using programming very heavily as a tool to accomplish other things. Like again, so essentially, I'm looking at electrical engineering as of right now with every software focus and going down that route. Potentially, maybe data science instead. I'm not sure. I'm kind of like 90% foot in the door for electrical engineering at this point. But then having heavy software focus. But then I started thinking about AI, and I had a really good conversation with a mentor of mine who's this guy who runs his own business like very successfully. He's had a very very lucrative career, and he's all about AI. He's 110% all about embracing AI. It's not even like a software company, actually. Um, Kind of deals more with finance and philanthropy, but he is all in on AI. He saw how software solutions kind of shook up the finance world, like how when Robinhood came out and there were no more broker fees, I think he said that it kind of just, and everyone had to get on that because it was just so competitive. Everyone had to adopt that sort of approach, just about. And I think he saw certain methodologies, paradigms, and even careers just evaporate with that. And now he kind of regrets not getting on developments and that sort of stuff and in social media when they were just getting big. But now with AI, he sees just how crazy it is, and he's used it a lot to help his own, um, organization, help streamline things and create like quality content, like at least minimally viable quality content with essentially with like no cost of real capital or man hour or anything of the sort. And it's just kind of changed the game for him. So he's really big on AI. We've had some long conversations on it. It's definitely here to stay. Definitely not a gimmick. But in terms of how much it'll take over the world, not literally take over the world, but in terms of how much it'll really revolutionize things and just completely change the face of how we do our work. I'm not entirely sure, but I don't know. I'm definitely going to delve more into AI myself. There's actually some pretty good courses on AI as AI and machine learning interfacing with Python. Um, I'll have to post it in the chat if anyone's interested. But yeah, I don't know. I don't think I'll specialize in it, at least at this point. It almost made me, I don't know, I got kind of excited hearing him talk about AI. It almost made me consider if I really want to go 100% into electrical engineering, maybe go back to computer science, blah, blah, blah. But I don't know. The excitement kind of came down from my excitement and realized that I think I'd still be interested in electrical engineering overall. And two, I mean, even with the utilization of like AI and the like, you still need people that are specialized that occupy a particular niche to be able to give expert opinion, be able to um, separate the wheat from the chaff in terms of what anyone produces, whether it's AI or data that's gotten through non-AI means, whatever it is. But anyways, I'll share resources by the end. For now, I'm just trying to build my own website as a starter. Nice. Yeah, definitely project-based approach will definitely it's definitely the king to things. Awesome. I work in systems area, multimedia, computer architecture, code optimizations right now. Good to know. So are you employed then as a software engineer at the moment? Or are you going to school? Or like what's your story? So anywho, oh, you just completed school. Nice. I just started back at school. I have a career in a completely different area right now, but I realized that I actually always liked STEM, and kind of makes no sense to not pursue it at this point, just with in terms of opportunity cost when factoring the next few decades of my life. So here I am. Oh, it's crazy. Anyways, what are we talking about? Serverless computing, cloud-based databases. So we talked about what databases are, why they're important, how they factor into web development, and we started touching on a little bit on how they interface with the cloud. But again, it's like we already talked about the fundamentals of like the fundamental benefits of the cloud, and that's essentially just what we're seeing, how they manifest, how those same fundamentals just naturally manifest in databases. So with that, let's keep going down here. So talked about web-based databases. So let's talk about the transition to web-based databases in cloud computing, just what that all brings. So the first is flexibility and accessibility. Web-based databases align with the flexible, remote access nature of cloud computing. They facilitate collaboration among distributed teams and allow users to access data from anywhere with internet connectivity. Second is scalability and elasticity. Cloud-based environments offer scalability and elasticity, allowing web-based databases to dynamically adjust resources based on demand. This ensures optimal performance during varying workloads. So cost efficiency, as we said, pay as you go. Organizations pay for the resources used, avoiding the need for upfront hardware investments and allowing better budget control. Managed services, reducing the operational burden on organizations. So routine maintenance, backups, and updates are handled by the cloud service, allowing teams to focus on application development. So again, I mean, this is kind of like the stuff that we covered in general, because this sort of stuff exists at the highest level. So no matter like how you get more detailed down from there, or whether it's databases or anything else, like those fundamental things that kind of define what cloud computing is are always going to be present. So web-based databases in the cloud can leverage global data centers, ensuring low latency access for users worldwide, CDNs, and further enhance global availability. We have security, adaptability, in terms of dynamic, interactive, real-time applications. Again, just pretty general stuff that we already know about now. So let's talk a little bit more on cloud-based databases in particular. Just a quick blurb on this, not too much. Then I'll go into content delivery networks. So NoSQL databases in the cloud. So cloud-based databases, particularly NoSQL databases, have gained prominence in web development due to their flexibility and scalability. So you've probably heard things like, MongoDB, Cassandra, DynamoDB. These are NoSQL databases designed to handle large volumes of unstructured or semi-structured data, making them well suited for dynamic web applications. So these databases are cloud native, meaning they are optimized to run on cloud platforms, offering seamless integration with other cloud services. And they have all of the benefits that we just talked about, like scalability, global accessibility, managed services, flexibility. So yeah, that's really it in terms of our little primer, at least in terms of databases. So what databases are, why they're important, why they're used in web development, non-web-based versus web-based databases, a bit more web-based databases, and then cloud-based databases, right? Which, as we talked about, those NoSQL databases are very prominent now. MongoDB, Cassandra, DynamoDB. I've personally have heard of MongoDB and Cassandra. I've definitely seen those names thrown around. So, in fact, let's see. I actually posted these resources before in the chat, and not before, but in my one stream. This website is really, really nice. It's called, actually, let me share my screen. Oh no, I just have, these slides are more just like a general overview is all. And diving deep into the details in terms of our discussion. I want to show you all a very nice website. So there's this website called roadmap.sh, which just kind of outlines a curriculum, an A to Z, on how to learn particular skills or particular tools, particular skill sets. So we can see that, different types of development skill sets you can learn here. There's also different tools, different skills. I started going through the Python one recently. Again, because when I was doing web development, I just focused on HTML, CSS, JavaScript. Realized I didn't really like it. So now I'm picking up stuff with Python. There's a few nice ones here that are definitely topical. So MongoDB would be one. So if you're interested in learning about, again, cloud-based databases, this certainly would help. What else is there? We have Docker and Kubernetes. We talked about with containers. Post that. And then we have, actually, yeah, one on Kubernetes. We have this. And it's cool because these development guides are really solid. In fact, what was the one that I just saw? I think it was AI and data science. The roadmap for this was developed by AI and data science team at this company called Cream, an Uber company. So, you're getting some pretty quality stuff when you have teams like that collaborating on these things. What was the last one? Oh, Amazon Web Services. So again, just pretty helpful stuff if you're really focused on the cloud. Oh, here we go. Look at that, DynamoDB. Containers, Kubernetes. Wow. In fact, this is very solid. Oh, oops. Sorry. Oh, so many things to look at. Anyways, this is roadmap.sh. Again, so there's stuff for MongoDB, Docker, Kubernetes, Amazon Web Services, and it takes you through this whole, there's like a whole curriculum here. And look, it's talking about like all the stuff that we started talking about today, cloud computing. The star of the show here, you have your different cloud service models. See on the right side here, databases, DynamoDB, NoSQL storage, containers, Kubernetes, so on and so forth. So if you want to learn this sort of stuff, this is definitely a gold mine, to say the very least. So I'll drop this one as well if I haven't yet. Boom. Okay, here, let me keep up with the chat here. So I've always been intrigued with electrical engineering and homework, but their concepts kind of bounce off my head. Yeah, that's the only thing. I actually haven't taken any electrical engineering classes yet. So things that particularly interest me are either mechanical engineering or electrical. I know that like in physics 1 and physics 2, I think physics 1 essentially covers the concepts that you mainly deal with in mechanical. Physics 2 deals with concepts that you mainly deal with in electrical. And from there, a person can kind of get an idea of what they want to take. But then there's also classes like a step up from that. You can take like statics for mechanical, and you can take like circuits for electrical. So I guess from there, I'll see what really piques my interest. But I don't know. Honestly, in a perfect world, I think I'd go for mechanical engineering and be like heavy software focused, and maybe even do stuff with mechatronics, like where mechanical and electrical interface. But it seems like electrical is a much more in demand and safer bet. Not that like mechanical is impossible, but I don't know. I find both interesting at the end of the day. So I don't feel like I'm passing one up for the other. But let's see. Open source projects. Roadmap.sh. Super cool. Open source projects. Love that. Yeah, I don't know. It's a really good resource. I've been using it to just teach myself the actual like fundamentals of like computer science and programming. So I've only just now, I've been doing programming for about a year and a half, but it's just very hyper specific HTML, CSS, JavaScript stuff. So I'm just now going on to learn like data structures and algorithms. Then I'll go on to learn like, I don't know, like object-oriented programming and whatever the Python track is, I'll follow that. Been working through that Automate the Boring Stuff book with Python, doing little projects here and there. Going through this stuff, I have to cover all these things, and we'll see. I guess like the biggest thing too to keep in mind is like, because this will definitely get you going, but I don't think you want to like kind of blindly. I guess there's something like Python. There's so many things that you can possibly do with it as well, like different areas that you can go into. Because you can do web development with Python. You can do like data analysis and data science with it. You can do, I'm sure there's a whole world of things to do. So that I'm still trying to figure out like what my ultimate goal is. I think I'm going to delve more into data science, data analysis, machine learning, that sort of stuff, just because it seems like it interfaces a little bit more directly with engineering. If anyone has any insight on that, I'd be curious. But anywho, with that, so cloud-based web dev tools and frameworks, we've covered serverless computing, we've covered cloud-based databases. So as we see here are just our little things, a little overviews of them. Serverless computing allows developers to build and run applications without the need to manage traditional server infrastructure. Cloud-based databases organize collections of data that can be easily accessed, managed, and updated, ensure data integrity, support complex queries, and enable efficient data analysis, contributing to the functionality and reliability of web applications. Last thing here are our content delivery networks. We've mentioned content delivery networks a few times throughout this stream so far. We haven't talked about what they actually are. Only talked about we've kind of just indirectly talked about them, but now let's shine a light on them. So a content delivery network is a distributed network of servers strategically positioned across various geographic locations to deliver web content to users more efficiently. The primary goal is to reduce latency and enhance the performance of websites and web applications by bringing content closer to end users. So, not the thing that I usually think about when it comes to the internet, but definitely foundationally important are like the actual physical parameters how this stuff works, even when it comes to distance from the server to the user. Just crazy. So that's what CDNs are, distributed network of servers. In terms of why they're important, CDNs significantly reduce the time it takes for users to access web content by serving it from servers geographically closer to them. This results in faster load times and a smoother user experience. CDNs distribute the load across multiple servers, preventing bottlenecks during traffic spikes. This scalability ensures that websites can handle increased user demand without sacrificing performance. And finally, bandwidth savings. CDNs cache static content like images, style sheets, and scripts on edge servers. This reduces the load on the origin server and minimizes bandwidth usage, leading to cost savings for website owners. So just to really appreciate what CDNs allow for, I wanted to cover very briefly like what solutions were like before CDNs came along. So before CDNs, websites relied solely on a single server known as the origin server to deliver all content to users globally. This approach had several drawbacks. Latency issues. So users far from the origin server experience higher latency, leading to slower load times. Limited scalability. Single server architecture made it challenging to handle large amounts of traffic, especially during peak times. And then bandwidth costs. All content requests were directed to the origin server, resulting in higher bandwidth usage and costs. So we can really come to see how CDNs kind of just spreading the work across different servers and bringing those closer to each particular user really goes on to make things infinitely more efficient. So in terms of how CDNs interface with cloud computing, CDNs leverage edge locations, which are servers deployed at various points worldwide. These edge locations are often hosted by cloud service providers, aligning with the principles of cloud computing. There's cloud integration, where many CDNs seamlessly integrate with cloud platforms, allowing businesses to combine the benefits of CDN services with cloud-based infrastructure for a comprehensive solution. And lastly, global reach. Cloud providers' extensive global network infrastructure complements CDNs, ensuring widespread content distribution and low latency access for users globally. So, and then lastly, just some last points on the importance of CDNs to cloud computing. As we already talked about, the global scalability and the efficiency of delivering static and dynamic content. Well, there's also just, I guess just the user experience too with low latency. So, I mean, kind of just stuff we already talked about. In all, CDNs have become a cornerstone in the architecture of modern web applications, enhancing performance, scalability, and user experience. Integrated with cloud computing, they form a powerful alliance that is crucial for meeting the demands of a globally distributed and data-intensive digital landscape. So with these three, serverless computing, cloud-based databases, and content delivery networks, embracing these three is pivotal for modern web development. These tools and frameworks empower developers to create highly scalable, efficient, and globally accessible web applications, offering a user experience that meets the demands of today's dynamic digital landscape. So powerful, powerful stuff. And it's kind of cool because, I mean, we're talking about web development with cloud computing, but again, these benefits of cloud computing are so fundamental that it kind of extends beyond even web development. It's just crazy. Okay, so with this, thought it'd be fun to bring this all together, everything that we talked about today. Just a bit of an overview. We talked about just cloud computing in general, delivery of computing services like storage, processing power, and applications over the internet, and all those advantages listed there. Talked about cloud infrastructure in terms of our cloud service models, as well as containers and microservices, like containers and microservices. And then our cloud-based tools and frameworks like serverless computing, cloud-based databases, and content delivery networks. I wanted to bring this all together by looking at a case study, specifically Shopify, and how it went on to embrace cloud solutions. So Shopify, I'm sure most of us, if not all of us, are familiar with Shopify, which is a prominent e-commerce platform. Very, very wide-reaching. Shopify themselves embarked on a transformative journey to leverage cloud computing solutions for their web development needs. Facing challenges with scalability, global reach, and infrastructure management, Shopify sought the power of the cloud to revolutionize their operations. In fact, if you're particularly interested in this, they have their own blog where they go over, they cover just all aspects of their software development. And they even have an article, very, very topical, called The Journey to Cloud Development, how Shopify went all in on Spin, one of their cloud solutions. So I posted these two in the chat, as you can see here. Shopify.engineering and the article on their cloud development journey, as they call it. So we're going to delve into some of the details here in terms of how they utilized everything that we've talked about. So facing challenges with scalability, global reach, and infrastructure management, Shopify sought the power of the cloud to revolutionize their operations. They had some initial issues that sparked this. Shopify's exponential growth in merchant count and transaction volume posed challenges for their existing infrastructure. Traditional servers struggled to handle the increasing demand, leading to occasional performance issues, longer response times, and difficulty maintaining a seamless shopping experience during peak periods. So recognizing the need for a scalable and resilient solution, Shopify decided to migrate to cloud computing platforms. They chose Google Cloud Platform as their cloud provider for its robust infrastructure and advanced set of services. And we'll talk about some of the different aspects of implementation. So for scalability, they, how could I phrase it? They pursued scalability with the Google Cloud Compute engine. So the implementation of it, of Google Cloud Compute engine instances, ultimately help them achieve scalable compute resources. This allowed them to dynamically scale based on demand, ensuring optimal performance during traffic spikes, such as Black Friday sales. Another implementation was global content delivery with the Google Cloud CDN. So Google Cloud CDN was integrated to enhance global content delivery. This reduced latency by caching and serving content from Google's global edge locations, providing a faster and more reliable experience for users worldwide. So database management with Google Cloud SQL. This provided a fully managed relational database service, ensuring data consistency and scalability without the burden of manual maintenance. Serverless compute with Google Cloud compute cloud functions. To optimize operational efficiency, Shopify adopted Google Cloud Functions for serverless computing. This allowed them to execute code in response to events without managing server infrastructure, reducing complexity. And then real-time analytics with Google Cloud BigQuery. So to gain insights into customer behavior and streamline decision-making, Shopify implemented Google Cloud's BigQuery for real-time analytics. This allowed them to analyze large data sets swiftly and make data-driven improvements. Now, in terms of the results and impact of this all, kind of touched on it a bit just with talking about the implementation of these things. As we talked about, to help them improve scalability, the CDNs help them with global reach and reduce latency. Cloud SQL, streamlined database management, ensuring data consistency and reliability. The serverless efficiency provided by the GCP Cloud Functions, reduced operational overhead. And again, it allows their developers just to focus on innovation and feature development, which ultimately accelerated their time to market. And then two, real-time insights. So overall, in terms of lessons learned and future considerations, Shopify's cloud transformation journey emphasizes the importance of scalability, global reach, and efficient infrastructure, right? We've said that a million times throughout this stream so far, because these are just the fundamental benefits of a cloud-based approach. So their emphasis on these principles ultimately just help them in their web development. The lessons learned include the need for and embracing new cloud technologies for ongoing innovation. As Shopify continues to expand its services, they are exploring advanced machine learning capabilities and further optimizing their cloud architecture for even greater efficiency. So their successful transition to cloud computing not only addressed their initial issues, but also positioned them as a scalable, globally accessible, and innovative e-commerce platform. Their story showcases the practical implementation of cloud solutions and their transformative impact on web development for real-world projects. So with that, that's kind of everything, really. We touched on these fundamental aspects. What's going on, Emma? Thanks for stopping by. So right now we're giving a stream on web development and the cloud. So I'll walk you through super quickly here. Web development of the cloud. Web development, the process of building and maintaining websites or web applications. The cloud, a network of remote servers hosted on the internet that store, manage, and process data, rather than on a local server or personal computer. So going into that, we covered a bit about web development from its very beginnings, where it was just text-based websites, completely text-based with hyperlinks, up to what we have nowadays. How cloud computing helps modern web development, and how modern web development is all the more embracing cloud computing for various solutions to its growth. Different models of cloud services. We can see infrastructure as a service, platform as a service, software as a service. We talked about containers and microservices, which are basically like architecture and development solutions that are heavily embedded, that very naturally work with the cloud and cloud-based services. Very important things to know about nowadays if you want to keep up on the latest developments in software. And we talked about cloud-based web dev tools and frameworks specifically, where serverless computing, cloud-based databases, and content delivery networks. And you can see like the overviews of them here. We spent quite a bit of time on each of these, but if you just want to condense down into each one down to a nice little overview. Serverless computing allows developers to build and run applications without the need to manage traditional server infrastructure. So the server infrastructure is kind of delegated to the cloud providers. That way developers can focus solely on like writing code and innovating software-wise instead of like having to worry about managing the servers and all of that. Cloud-based databases, just all the benefits that you would normally expect from databases, but with the benefits of the cloud in terms of like scalability, global access, so on and so forth. And then content delivery networks, distributed networks of servers to deliver web content to users more efficiently. The cloud is very much interfaced with that, just the internet fundamentally now. Then we talked about how Shopify, so we took all of these things that we talked about and we examined Shopify and how they ultimately went on to embrace the cloud 110%. In fact, they have a website, it's a blog where they go over the various software development practices, methodologies, so on and so forth. And they have an article here on their cloud development journey. So, yes, cloud. That's what we're all about. It's Cloud Week, in fact. This Global Hack Week is entirely dedicated to the cloud. So this is all about the interfacing of cloud and web development. And it's kind of funny because, well, I don't know. The cloud is just so, I don't want to say it. The cloud exists on such a fundamental level that we've touched on how it interfaces with web development. We certainly have, but we've kind of just focused on the cloud in general too, because what trickles down into web development from its like basic principles, the cloud, also trickles down into all sorts of other areas of just delivering software and so on and so forth. Yes, cloud is everywhere, that's for sure. That is definitely for sure. But yeah, now we covered Shopify. That was kind of the big climax of it all. With this Shopify case study, we're able to touch upon everything that we covered today. So, anywho, I had a bit on different resources that you guys can access. So we talked about it a little bit before. If you want to learn more about web developer, about just the cloud, some good resources are definitely going back to that roadmap site. In fact, let me just post this in the chat. So we have this roadmap site that has these different roadmaps, hence the name, for different software skill sets. So if you want to learn more about, probably the biggest one, if there's anyone here that wants to learn more about the interfacing of web development and cloud computing, would be this one for Amazon Web Services. Huge, huge, huge. In fact, I'll post this in the chat again. So if you go through here, you'll start to see a lot of what we talked about. So you can click on any of these boxes and it gives you an overview of just what everything is. So we'll click on introduction and gives us a write-up on just an introduction to Amazon Web Services. And then it goes into here when we learn about cloud computing. Like we talked about like these service models earlier. So again, things that are ringing a bell. Let's see. This stuff I haven't delved into at all myself, so I can't comment upon it. But again, these roadmaps are put together by very competent teams. Like the AI and data science one, as we looked at earlier, was put together by an Uber company. I think it's called Kareem. So they have very high-level vetted contributors to this, it seems, at the very least. What else is there? I don't know. This is definitely the place to go if you really want to get in detail in terms of like, because yeah, we mainly talked about concepts today, more of a general overview. But if you really want to get into the nitty gritty and pick up some skills yourself, definitely check out this this roadmap here. So, okay. Well, with that, we can have a couple minutes. If there's any final questions or the like, by all means, throw them out. But in just a couple of minutes, we're going to be joining Wei for a Docker stream. So if you want to learn more about Dockerization, containerization as a whole, definitely stick around. But I'll be on here for a couple more minutes. If anyone has any questions or points of discussion, by all means, let me know. Thanks for the great session. Yeah, thank you so much for joining me. I really appreciate you guys. It's nice seeing the regulars too. Kind of having it's nice to have continuous conversations and able to interface with people across streams. I really enjoy that. Okay, I'll wait another minute or so, see if anyone's got anything to drop in chat, but we are certainly winding down now. Docker after intro to containerization as well, or works well. Yeah, definitely. There we go. Yeah, that's the thing. It's like kind of naturally follows from this stream in a way, since we covered containerization like in good enough detail. So that should give you enough to appreciate Wei's stream all the more. Okay, let's see. Great session. I will try integrating them, then real questions might come. Yeah, I definitely feel that. Definitely a big world to look into. But well, I mean, you know, if you're interested in learning a bit more about the cloud, or even just delving into the cloud full force, I hope this stream gave a good overview of just things to be cognizant of, things to be aware of where to look, and then resources like, say, this roadmap. Definitely help you with learning like concrete hands-dirtying skills. So, well, with that, thank you everyone. Appreciate you all stopping by and joining us for today's stream. With that, don't go anywhere. We are going to be doing the Dockerization stream in just a second. So I'll see you all then. Have a good one.